And we're into 3.4. Now we're going to be talking about this new thing, some kind of quadratic formula. So we're still dealing with quadratics. We're carrying on. So far we've looked at first method of solving our quadratic equations. First method that we learned about was factoring. So we could factor it. Second method that we learned about was completing the square. We're looking at now the third way. The third way is going to be this quadratic formula. But look at this here. Use the completing square to develop the quadratic formula. So it's going to be based on that. All right, let's just remind you how we can solve. Well, first thing, let's look at the first one. Can we factor that? No, there's no way we can factor two numbers that multiply to -2 and add to -2. Factoring is not an option. It's not factorable. So we're going to go to the second one. Hey, completing the square. We can do that. Take the 2 over to the other side. X squared minus 2x plus something equals, positive 2 plus something. Let's figure out that something again. Take it on the side, the middle term, -2. Always divide by 2. Squared. So we've got -1 squared, which gives us 1. That's what goes in and comes out. And we know the left side, we made it. Let's factor it. X, always the minus, 1 squared. Equals 2 plus 1, that's 3. And square root both sides. Gives us x minus 1 equals plus or minus the square root of 3. Don't forget about plus and minus. And now, last one, add over the 1. X equals 1 plus or minus the square root of 3. Means again, we've got 1 plus root 3 or 1 minus root 3. Those are the exact values. Uh-oh. What happens if we don't have numbers? We just got letters there. Well, we're going to do it exactly the same way. The process is what's important here. X squared plus bx plus c equals 0. C is the constant. Doesn't have the x. Let's take it over to the other side. X squared plus bx equals -c. Now we've got to go and do x squared plus bx plus something equals -3 plus that same thing. We got to figure out that something. It's the exact same process. We're taking the b off to the side, always divide by 2, and always square. Well, that means b squared over 4. Put it in. I just made that left side. I know what it's going to factor into. X plus, same sign, the number right before you squared it. B over 2 squared equals. I need a common denominator to bring these two together. So I've got to take a common denominator of 4. That gives me c over 4. Got to multiply it by 4 so that I get the common denominator of 4. So now we've got negative 4c plus b squared over 4. I don't like having that negative in front. I'm going to rearrange that. Let's square root both sides. Gives us now x plus b over 2 equals plus or minus for the square root. We got plus or minus the square root. I'm going to give the numerator and the denominator its own square root. B squared minus 4c over, well, look right there, square root of 4. Oh, that's 2. Notice that I've taken the square root of the 4. Last step, let's subtract over the minus b over 2 to both sides. Oh, nice, they have common denominator. That's going to be helpful. X equals negative b over 2 plus and minus the square root of b squared minus 4c over 2. Bring them together into one fraction, negative b plus and minus square root of b squared minus 4c over 2. Well, this is a cool little thing that pops out, but it only worked when we had 1x squared plus bx plus c equal to 0. I want to be able to use this when I've got some other number instead of 1 in front of there. So what this is saying is any value that, any quadratic that you have, when you've got a b value there, whatever it be, 2, 5, 8, you're going to plug it in straight into the b value here. Whenever you've got a c value, you plug it straight into there. Work it through, and you get straight to your answer. You don't have to complete the square, because we just did it all the way through. But this only works when we have a 1x squared. Let's flip the page and see what they do there. Now we're going to talk about an a value that's not 1, a b value, and a c value. Here's your process, exactly as we just did. Taking our a value and dividing it all by that coefficient, because we want to get a 1x squared here again. So we divided everything. So now we got b over a. We got c over a. Then we're going to take that c over a to the other side. Gives us this one here. Then we do the divide by 2 or multiply by 1/2 to the b over a. That's the middle term there. Add the somethings in to both sides. Factor the left side. We know what it's going to be. Right before you squared it was b over 2a. Square root both sides. And then we're going to simplify that square root. The 4a squared goes down to just 2a. And then we bring over the b over 2a. Oh, nice. They both have the same common denominator. Bring it together. And this is what we call the quadratic formula. So when we're looking at the quadratic formula, what we're going to be doing, we're going to be saying, okay, the a value in front, plug it in for where there's an a. Then a b value. Whatever the b value is in that spot, plug it in for where there's a b. The c value, plug it in for where there's a c. Work it through, you got your answer. Works every time. Let's use it here. First thing we want to do, let's bring down your formula up at top. X equals negative b plus and minus square root b squared minus 4ac all over 2a. All of it, notice that the divide sign, the fractions all the way over. Okay, let's figure out what we got. First one, a value's in front. The b value, the c value. It's got to be equal to 0. That is a key here. In order for the quadratic formula to work, you have to make it equal to 0. So it's a formula-based question. Take your formulas on the side. A is equal to 1. B is equal to 2. C is equal to 7. We're just going to plug it straight in. Start with writing the formula, then substitution, then work to your answer. So we want to write the formula on each question. Negative b plus and minus square root b squared minus 4ac all over 2a. Now we plug it in. Minus, there's the 2. Substitute with brackets always. 2 squared minus 4 times 1 times 7 all over, make sure that's extended, 2 times 1. Now we're going to start simplifying and cleaning it up. And so now we got negative 2 plus and minus square root 4 minus 28 over 2. Simplify it up. 4 minus 28, negative 24 over 2. Whoa, wait a minute. We got a problem here. We're taking the square root of a negative number. What that's going to mean for us here, can't take the square root of the negative number, so therefore there's no solution, or no roots, no real roots. No solution. No value of x will make this a true statement up at the beginning. But just by changing that positive 7 into a negative 7, let's see what happens now. Again, starting by labeling, a is equal to 1, b is equal to negative 2, c is equal to negative 7 this time. Start with your formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. And start plugging in with brackets. Negative 2. Oh, we changed the 2 and the 7. Plus and minus square root of negative 2 squared minus 4 times 1 times negative 7 over 2 times 1. We've got negative 2. That's positive 2 plus and minus square root. Negative 2 squared. That's why we needed brackets here. That's 4. Positive 4. Negative 4 times the negative 7, that's plus 28 now over 2. So we've got 2 plus and minus square root of 32 over 2. This is where you got to be able to simplify your radicals now. That 32, take it over on the side, square root of 32. That can be broken down to the square root of 16, a perfect square, times the square root of 2. Square root of 16, that's 4 root 2. That's what we're going to be bringing back in here. 2 plus and minus 4 root 2 over 2. This is the problem that lots of students will make. They say, oh, could I just cancel off those 2's? No, you cannot. The reason you can't cancel them off, because you're going to have to take that 2 from everything. What I like to call giving them all the love. You got to give all of the numbers, not the ones inside the square root, but all the ones in front. You got to give them all the love. They all want to be divided at the same time. Everybody needs love. So now I've got to look at those 3 numbers. The 2, the 4, and the 2. What can you divide all 3 of them by? Well, we can divide them all by a 2. So hiya, that gets us to 1. Hiya, that gets us to 1. Hiya, that gets us to 2. Now we've simplified it. The answer now is going to be 1 plus and minus 2 root 2. All right, let's take it to trickier types. Oh, boy. Not equal to 0. So we first have to expand and then equate to 0. So let's expand it first. So we get 2x squared minus 2x plus x minus 1 equals 5x. Collect all of our like terms. And let's equate to 0 at the same time. 2x squared. Negative 2x plus 1x gives us negative 1x. Bring over the negative 5x, so negative 6x minus 1 equals to 0. Now we've got a, b, and c that we can use. A, b, and c. Let's plug it in. Start with your formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. Let's fill it in. X is equal to negative 6. Brackets are necessary here. So negative 6 squared minus 4 times 2 times negative 1 over 2 times 2. Simplify it up. That gives us a positive 6 now. Plus and minus. Negative 6 squared, 36 positive, plus 8 over 4. Which gives us 6 plus and minus the square root of 44 over 4. No, you can't take stuff out of the 6 and the 4. No, you can't bring that 44 into play there and start dividing things out. They don't get to play together. You've got to give them all the love. We don't, right now, all we have sitting in front is a 1. 6, 1, and 4, nothing you can do. So we got to simplify that 44 down. 44 can go down by dividing out square root of 4, multiplied by square root of 11, 2 root 11. Let's bring that back in. So 6 plus and minus 2 root 11 over 4. Now we can give them all the love. Oh, it's just so sweet. Hiya, can divide them all by 2, that gives me 3. Hiya, that gives me 1. Hiya, that gives me 2. We're now sitting with 3 plus or minus square root of 11 over 2. Done deal. Everyone's favorite, fractions. What we're going to do is get rid of the fraction to start with on a question like this. So, bracket off each one of them, multiply all terms by, same as always, LCD. LCD is going to be 4. So I'll put a 4 beside each one of them. We're going to multiply them each by 4. 4 times a half, that's 2x squared. Look at that. 4s are going to cancel off. We get 5x equals 12. Don't forget to multiply the 3 by the 4. That's where people make mistakes on these. Let's equate it to 0, just like regular. 2x squared minus 5x minus 12 equal to 0. And label our A, B, and our C. Formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. Plug her in. Negative 5 plus and minus square root negative 5 squared minus 4 times 2 times the c value, negative 12, over 2 times 2. Let's simplify it further here. Negative 5, that gives us positive 5 now. 25 plus 96 over 4. 5 plus and minus 25 plus 96. Oh, that's 121 over 4. Oh, but wait. 121. That's a special number. That's a perfect square. The square root of 121 is 11. 5 plus or minus 11. Not the square root 11. Just 11 over 4. Don't leave it like that. We can actually evaluate that one further. So we've got 5 plus 11 over 4. Should say x equals. Or x equals 5 minus 11 over 4. 5 plus 11, 16. Divided by 4. Oh, that's 4. Or 5 minus 11. That gives us negative 6 over 4. Take that to lowest terms. Negative 3 over 2. There's our 2 answers. Woo! Always got to finish off with a crazy one here. Surface area of a cone with radius r and slant height s is given by that formula. Oh yeah, we learned that already. A cone has a surface area of 300 centimeters squared and a slant height of 15 centimeters. What is the radius? Ooh, working some backwards stuff here. All right, let's fill it in. Start with the formula they gave us. A equals pi r s plus pi r squared. We've been given that our surface area, A is equal to 300, and our slant height, S is equal to 15. Let's plug those in. So 300 equals pi r times 15 plus pi r squared. All right. Remember that pi is a number. It is not a variable. Let's clean this up. And, hey, we've got a quadratic here. Hey, let's equate to 0 on this guy. So I'll bring the 300 over. So pi r squared, pi is a number, plus 15 pi r minus 300 equals 0. Now we've got A, we've got B, we've got C. A, B, and C. Let's fill it into our quadratic formula. Except this time, it's not x equals. There is no x variable. It's r equals negative b plus and minus square root b squared minus 4ac over 2a. Bring them in. We've got negative 15, in brackets, negative 15 pi plus or minus, that whole thing is the b, plus or minus the square root of 15 pi squared minus 4 times the a value, pi, times the c value, negative 300. All of it over 2 times pi. Woo-wee! Let's keep this going. We now get negative 15 pi plus and minus the square root of 15 squared to 25 pi squared plus 300 times the 4, 1200 pi, all over 2 pi. No, you can't cancel off those pi's. They got to stay there. That's actually as far as we're really able to take it. So now we just break it off into the two parts. R is either equal to negative 15 pi plus the square root of 225 pi squared plus 1200 pi over 2 pi, which we'll punch into our calculator right away. Or x is equal to negative 15 pi minus the square root of 225 pi squared plus 1200 pi over 2 pi. Whoa, but wait. A negative and subtracting off more negatives, this is going to give us a negative number. We're talking about r. We're talking about, oops, not x. I don't know where that came from. We're talking about r. We're talking about the radius. There's no way the radius is going to be a negative number. We don't worry about the negative part. We're only going to work with this blue one in the positive. We punch that into our calculators. Carefully, brackets there. If you're doing it in one step, bracket all numerators and denominators, or do it in a few steps. Punch it in, and I want you to actually punch this one in to make sure that you do get the right answer from here. You know how to use the calculator. 4.8183 dot dot dot. R is approximately 4.82 centimeters. Ooh, that was fun. All right, 3 quick questions. Okay, y, no more than 2 roots. Quadratic formula, what happens if a, b, c, 0? Quadratic formula, when? So answer those 3 questions up for yourself. We'll talk about them. See you in class.